is also 1, so we get 9. The next GCD is a GCD of 4 and 9, which is also 1. So at the fourth term, we also step up by 1 to 10. The terms so far are 7, 8, 9, and 10. So far, this is a pretty boring sequence, but now something interesting happens because the GCD of 5 and 10 is 5. So here, the sequence jumps up by 5 rather than 1. The next GCD is a GCD of 6 and 15, which is 3. So the sequence jumps up again, this time by 3. Then we go back to stepping up by 1 for a few terms. And we reach the bottom of the frame, so let's make room for more terms. This sequence was discovered in 2003 when Stephen Wolfram initiated several experiments exploring the space of possible recurrences. Initially, what seemed to be remarkable about this sequence is that it exhibits long stretches of boring behavior, interrupted by sudden jumps, and it's not obvious that we can predict the jumps in advance. But even more surprising is what the jumps are doing. Let's look at the GCDs on their own, because they determine whether the terms of the sequence are increasing by 1 or making a jump. Collecting the GCDs into their own sequence makes the behavior a little easier to see. Let's gray out the boring ones and include more data. Notice anything? Let's be really drastic and remove the ones entirely. Here's even more data. Surprisingly, all these numbers are prime. Remember that these numbers are GCDs, so it's not crazy that they have something to do with visibility. But why on earth are they necessarily prime? Pause the video if you'd like to stare at these primes for a bit, because there's some patterns that may jump out if you look at them long enough. If you see something, let me know in the comments which numbers first gave it away. This way we can do a little psychology experiment and see whether the same numbers jump out to most people. For me, here's what jumps out first. 60647 is very close to 2 times 30323. In fact, they're just off by 1. There are other pairs like this too. 2 times 5 plus 1 is 11, 2 times 11 plus 1 is 23, and 2 times 23 plus 1 is 47. Unfortunately, the pattern doesn't continue, since 2 times 47 plus 1 is 95, which doesn't appear and also isn't prime. But there are several other pairs sprinkled across the data that do satisfy this doubling relation. Why does it work in certain places and not others? Also, why is there a 3 sandwiched between each pair? And again, why are all these numbers prime? This was the state of things in 2003. No one knew. I had just graduated from college. I was eager to prove an interesting new result about primes, so I worked on this sequence for a bit, but didn't get anywhere. But several years later, I had an idea to try something I hadn't thought of before. To see what's going on with the sequence, it turns out that we need some information that we threw away. So let's put the primes back in their positions and bring back all the ones. The information we shouldn't have thrown away is the index n corresponding to each of these GCDs. After all, each GCD is the GCD of n and Rn minus 1. Now we can safely throw away the ones again. My idea was to make a plot of this data, but ignore the primes themselves and only plot the index n where each prime appears. So that's 5, 6, 11, 12, and so on. Since there are many ones in the sequence of GCDs, this sequence, the indices of GCDs that aren't 1, grows quite quickly.我们这个全新的漫画系列将会讲述一段有关口袋茉莉的故事，就让我们先来说说什么是口袋茉莉好了。不给网口袋妖怪自编包围时期就是高人气的游戏，这种收集与战斗并重的游戏设计一直广受欢迎。于是为克里莫蒂的东家 Adult Swim 制作了一款相同玩法的手游《口袋茉莉》，而为了吸引更多粉丝游玩，制片人贾斯汀·罗兰德亲口承认了口袋茉莉的正传性质，其剧情可以被当作官方剧情。